Class number 26. In the previous class we discussed about the concept of VLAN IDs, and in this class we will discuss about the different type of switch mode which is trunk and a logical interface called VLAN interface. So in this class we will build this topology. So we have PC1 in 192.168.1.1 network, and we have PC2, it is on 192.168.2.1 network. So we have PC1 and PC2 are different subnets. Okay, so in order to make communication between PC1 and PC2, there should be some gateway. So they are currently directly connected to a switch. So to isolate the traffic, broadcast traffic from PC1 to PC2, what we did is we created a VLAN 10 and we assign it for the PC1 network, VLAN 20 where it is connected to the PC2 network. So if we have, for suppose, PC3 in the same subnet as 192.168.1.1, we connect it to VLAN 10 so that broadcast frames like ARP request will only reach the devices in the same network. Similarly, if you have more devices you want to connect in this network, example PC4, you will do the same thing. You take another interface and assign the VLAN ID 20 so that these two PCs will be in the same part of the same logical switch, means same broadcast domain. Okay, so if we have this kind of setup and we have a switch here, okay, so we created two VLANs, means logically we created two logical switches, VLAN 10 logical switch and VLAN 20 logical switch. That is good. And in order for PC1 to ping PC2, the packet needs to be sent it to the gateway. Let's say we have gateway here. Okay, so for the PC1 network, gateway will be 192.168.1.254. okay, so let's say we assigned it here. So let's see what will happen when PC1 wants to send a packet to PC2. PC1 needs to include the destination MAC address of its gateway, right? So for that it will send a ARP request. So it will reach switches interface Ethernet 1, and here we are not we did not configure anything, right? So in order to send this ARP request out of this interface, we need to put this interface in the same VLAN 10. Okay, so then it will go here. That is fine. Okay, we did this. Then next, look what we can do for the PC2 gateway. PC2 gateway also assume it is here. Let's say we have another cable, because we cannot allow the same access with the switch port access mode VLAN 10. We can only put only one VLAN on the access mode. Okay, that's why we are using another cable, let's say. So if we use another cable for VLAN 20, we assign it access mode VLAN 20 here, so that whenever PC2 sends an ARP request for the gateway on this interface, it will come here and switch will send it on this interface. It will go here. Imagine that like that if you have like 10 VLANs here. So in this topology you have to connect 10 cables, assign access mode each VLAN for each interface on this side. So this is not feasible when you want to connect multiple networks using the VLAN concept, right? So let's see how we can resolve this using the concept of trunk and VLAN interface. So switch port mode can be like two types. One is access mode, another is trunk mode. Access mode is just specifying only one VLAN. Trunk is it can allow multiple VLANs. Okay, so in this topology, PC1 we kept it in the VLAN 10 and PC2 we kept it in the VLAN 20. So we have three logical switches here. One is with the default VLAN 1 and another one is VLAN 10, another one is VLAN 20. Now on VLAN 10 we have Ethernet 1, VLAN 20 switch we have Ethernet 2. So in order to use the same physical link for the both VLANs, we need to allow both VLANs here. So on Ethernet 3 we make it as the trunk port. So trunk port we allow both VLANs, VLAN 10 and 20, means this Ethernet 3 is shared between VLAN 10 logical switch and VLAN 20 logical switch. So Ethernet 3 is part of both logical switches VLAN 10 and 20. And we do the same thing here. So in this topology, instead of just using the router, we are using multi-layer switch. So in our lab, we have the multi-layer switch. So multi-layer switch means it can act as a switch. Also, it can act as a router as well. So it can do IP routing and it can do switching as well. So we are doing the same configuration on the other side. Okay. So let's see how we can do this configuration. So on the switch side, here we are creating the VLAN 10 and VLAN 20. So VLAN 10, VLAN 20, and we are assigning Ethernet 1 to the switch port mode access VLAN 10, and same Ethernet 2 for PC2 switch port mode is access, and we are allowing the VLAN 20. So far we are familiar with this setup because we discussed this concept in the last class. So let's see how we can configure the trunk. So we go to the interface, and now instead of switch port mode access, we specify it as trunk. So we can allow multiple VLANs here. So the command is switch port trunk allowed VLAN 10 and 20. So once we configure this, you can see that Ethernet 3 is part of VLAN 10 logical switch, also part of the VLAN 20 logical switch, and 191 is part of 10, 2 is part of 20. Because these two are access, we are only allowing one VLAN. On Ethernet 2 we are allowing multiple VLANs 10 and 20. Okay, so whenever ARP request comes from PC1 to VLAN 10, it can go here. Same whenever ARP request come from PC2 to its gateway, when it comes on VLAN 20 Ethernet 2 here, it can go here as well. So now Ethernet 3 can pass both VLANs 10 and 20 VLAN related packets or frames. So we will do the same configuration on the multi-layer switch as well. So here we need to allow two VLANs. So we make this as trunk. So first we need to create the VLANs, and then on Ethernet 3 we are allowing these two VLANs. So as you can see, Ethernet 3 is part of VLAN 20 and VLAN 20. So Ethernet 3 is a shared interface between VLAN 20 logical switch and VLAN 10 logical switch. So this is good. So now in order for the make communication PC1 and PC2, because they are in the different networks, they should have a gateway in their own network. So .254 should be for the .1 network, 1.254 should be here, and for the 2.254 also should be here. So usually we assign the interface IP on the Ethernet 1 on the physical interface, right? But here we only have one physical interface, and we define that as a switch port. So on the switch port you cannot assign an IP. Also you cannot assign two IPs on the same Ethernet, right? So that's why it is not possible to create assign IPs on the same physical interface. So how do we create gateways on this multi-layer switch using the Ethernet 3? So we use a concept called VLAN interface. That's a logical switch. So for each VLAN we can create a logical interface, and that will be based on the physical interface. So in this topology we create two logical VLAN interfaces on top of Ethernet 3. So let's see how we can do that configuration. We enable IP routing because it's a multi-layer switch. You can enable routing services by this command. And next, instead of interface Ethernet 3, here we are using interface VLAN and VLAN ID. So now we are creating a logical interface for VLAN 10, and you can assign the IP to that VLAN interface. So here I am assigning 192.168 1.254, which is the PC1 gateway. So I am assigning this to VLAN 10. Same, I am doing the same thing for VLAN 20, and the gateway is 2.254. So if you do show IP interface brief, VLAN 10 and VLAN 20 has the IPs and their status is up. So the status depends on the actual physical interface. Okay, for suppose if you shut down Ethernet 3, what will happen is these three interfaces also will go these two interfaces also will go into shutdown state, because they actually built upon the physical interface Ethernet 3. Whenever a packet comes to this interface, it needs to send it on Ethernet 3, right? If the Ethernet 3 is down, there is no way the multi-layer switch can forward the packet. So VLAN interfaces are dependent on the actual physical interface where the VLAN IDs are assigned. Okay. So if you look at the routing table now with the show IP route command, you can see there are two directly connected networks to this multi-layer switch. So we did not assign IP to Ethernet 3. So if you can see the routing table, 192.168.1.0 is directly connected to VLAN 10. So whenever router receives a packet with destination IP in this network subnet, it will send it to VLAN 10, means it will send it to wherever the VLAN ID assigned. So in this case, Ethernet 3. So same thing happens when a packet comes with the destination IP in this subnet. It is need to be sent to VLAN 20, means the physical interfaces still remain the same one, Ethernet 3, because it's a trunk port and it is allowing both VLANs 10 and 20. So we configure the VLAN interface on top of Ethernet 3. So now if you try to do a ping from PC1 to PC2, what happens is PC1 sends it to VLAN 10, it comes here, and once switches receives this, it will send it to this VLAN 10, and it is allowed on this spot here, Ethernet 3. Then it will go to the logical interface. So as the packet is coming from the VLAN 10, it will go to the logical interface of VLAN 10. Okay. Once it's arrived on the VLAN interface, router will check the routing table. So the routing table here, it says to reach 2.0 network, it needs to send it to VLAN 20. Now the packet needs to move from VLAN 10 to VLAN 20. So interface VLAN 20 will send the packet to wherever the VLAN 20 configured. So in this topology, it is still on Ethernet 3. So what happens is, on the physical level, the packet went on Ethernet 3 and came back on Ethernet 3. Okay, but inside it traveled between two logical interfaces, VLAN 10 and 20. Okay, so once it comes here, it will go on this port VLAN 20 and reach the PC2. Same thing happens for the reply packet. When PC2 sends the reply packet, ping reply, it will go here and it will cross the two VLAN interfaces and comes on the same physical Ethernet 3 and comes down to the PC1. Okay, so build similar topology and configure the trunks and VLAN interfaces and verify the connectivity between PC1 and PC2. So in this topology, if you would like to add another VLAN, let's say you want to add VLAN network 30. So normally the commands you need to use switch port trunk allowed VLAN add 30. So what this will do is, existing we already have 20 and 20 VLANs. With the command switch port trunk allowed VLAN 10 and 20, when you use add, what it will do is it will add VLAN 30 to that list. Okay, and another way is you can mention all the VLANs again you want to allow it on. So in this case, you are specifying the existing VLANs and the new VLAN as well. So both commands should work. But what happens when you use this command? So the existing VLANs are 10, 20 are there, but if you just specify switch port trunk allowed VLAN 30, means now you are telling the switch allow only VLAN 30. So in this case, what it will do is it will remove the existing VLANs. Okay, and it will only add 30. So what happens to the devices connected in those two VLAN IDs? So they will be isolated, they will go down. Okay, because if you look at the topology, once you remove 20 and 10 and 20 and add 30, so there is no way packets from VLAN 10 and 20 can reach towards the gateway. Okay, so make sure you use the keyword add, or you mention all the VLANs that you want to allow. Okay, That's all for today's class. If you want to like add the VLAN 30, you can take a PC 3 and put them in a different network, add the VLAN 30 in the trunk, and you can create a VLAN interface on for VLAN 30, and you can test the connectivity between PC 1, 2 and 3. Okay, that's all for this class. Thank you.